multiples. Factors and multiples. Take some number. We have taken 30. So factors of 30 are 1, 2, 3, 5, 6, thereafter 10 and 15 and 30 are the factors of 30, because here the factor is nothing but the number what we have taken that is divisible. So this number 30 by 1, it's possible, it's completely divisible, and 30 divided by 2, it's completely divisible. So when we divide a number with some other and then we got a result, remainder 0, and that is called as factor. We have discussed in previous chapter. So 30 divided by 2 is there is no remainder, and 30 divided by 3 there is no remainder and completely divisible. So 30 divided by 5, so 6, and here 30 divided by 6, 5 and 3 and 2 and 1. So after division of these all the numbers, and then we get a result and that are completely divisible. So these are called as factors. When we divide with some number, we got there is no remainder. So these are called factors of 30. So these are the factors of 30. 1, 2, 3, 4, 1, 2, 3, 5, 6, 10, 15, 30. We call them as factors of 30. So let's take some of the factors from it that are only prime numbers. We know that the prime numbers are nothing but which are having the factor 1, which are divisible by 1, and the number itself are called prime numbers. Like for example, we take 5 is divisible by 1 and 5 is divisible by 5. Only these two numbers are divisible by 5. Except these two numbers, there are no numbers are divisible by 5. So this kind of numbers are called as prime numbers. So already we have discussed about the prime numbers in previous class. So these are the prime numbers 1 and 5. But the factors of 5, and there is no other factors, the numbers which are having only two factors are called as prime numbers. So here let's choose prime numbers from these all the factors. Only prime numbers that are is a prime number. The reason is it has only two factors, 1 and 2. The next is 3. 3 is also prime number because it has the factors of 1 and 3. So next one is 5. It has the factors of 1 and 5. No other factors for it. So there is 1. It doesn't have any other factor. 1 is a factor of 1. So itself, so it doesn't have any other factor. 1 is not neither prime nor composite. So 1 we will leave it. So 6 meant we have more than two factors. 10 more than two factors. 15 also more than two factors. 30 also more than two factors. So these are our prime numbers. And then we have taken prime numbers from it. So prime and it's the factors of it. So factors, prime factors we have taken. So these are the factors of 30 and as well as the prime numbers. So prime factors are 2, 3, 5. So what we understood is that the factors of 30 and especially we have taken the prime numbers from it. We call these prime factors of 30. So how we can say these are prime factors of 30? 30 is equal to, we have taken 30. Let's multiply these prime factors. Let's see we are getting this 30 or not. So 2, 3, 5. Let's find out the product of it. 2 into 3 into 5. So 2 3s are 6, 6 5s are 30. So we are getting here 30, the product of prime factors of this number. So what we understood is that we have taken a number and find out the prime factors of those numbers is equals to the product of the those prime factors is equals to that what we have taken the number. So we understood the concept of prime factors. So we'll apply this same concept for an expression which is having a variable and a constant value or anything. Well, expression is nothing but the combination of, let's discuss about the expression. Expression is nothing but when we have taken any variable, for example x, and is added to another variable y. It's called an expression. It's not only that, we take the variable and constant number together is called an expression. The combination of variable and variable, or combination of variable and constant under the operation of addition, subtraction, multiplication or division is called as expression. So for example, x minus 3, x into 3 or x by 3 with any terms. So here the expression is this, what we have taken, the variable and constant, and if we have taken, there is only one variable, we know that we have learned this one variable we have taken, there is our one constant number we have taken, this is called as term. This is called as term. So let's see here how many terms are there. There are two terms. So expression can have minimum one term or more than one term, and unlimitedly we can have expression terms like for example x plus y plus z plus a plus 3 plus or something. We can write the variables and to continuously. So an expression can have variables unlimitedly. So that is we discuss about the expression part. So finally we can factorize an expression which is having the variables and constants. So let us see how we can factorize the expression. So factorize an expression. So if we take any expression, for example 30 xy, it's a combination of the variable and constants. The constant value is 30, the variables are x and y. So let's find out the factors of it, because factors is nothing but the product of all the factors of a given number is called factorization. So if we take any number or any value and we take the product of those factors of that number is called factorization. So let's find out what are the factors for this number, this expression 30xy. So when we take the factors, the prime factors for 30, we'll take, especially we use only prime numbers for this. We know that we have done already for 30, it is 2 into 3 into 5, because 2 into 3, 6 5s are 30. Then x can be written as x only, there is no other factor for the x, into y. So these are called as, these all the terms are called as the factors of 30xy. So what are the factors? Let us see. 2, 3, 5 and x, y individually are called factors of 30. So why we call these are factors of 30 is, let's take one of the expression, factorize that expression. 18x cubed minus 14x squared plus 10x. So this is the expression. We need to factorize this expression. To factorize this expression, first we need to know the prime factors for 18, the prime factors for 7. the prime factors for 14, the prime factors for 10. So after finding the prime factors of those numbers, and after we'll take the factors of x cube and x square and x. After finding the values for x cube variables also, then we'll write in those places. Let's take this first term. This is the first term, second term and third term. So let's take the first term. First term is 18x cube. So when we factorize 18, only 18, we are taking the 18. So 18 is, let's take the first prime number, 2, 3, 5, 7 and so on, the prime numbers. The first prime number is 2. So 2, let's divide. So 9. So 2 will not be divisible by 9. So let's take some other number. So 3. So 3 is divisible 3 times and 3 table 1 time. So we get here 18 is equals to 2 into 3 into 3. So we got the prime factors of 18 are 2 into 3 into 3. So let's write here 2 into 3 into 3. Then we know that for expression, for any expression, x cube can be written as x into x into x. So x cube is equals to x into x into x. We have learned the rules of a power m into a power n. So exponents and powers, in that a power m into a power n is a power m plus n. Similarly, here we added this, the exponents of this variable. So 1 plus 1 plus 1 is 3. So x cube can be written as x into x into x. So let's write this x cube as x into x into x. So next one, the next second term is 14x square. So let's write the 14x square, and then we need to factorize 14. We need to take the prime factors for 14. So first prime number is 2. So 7 times. So there is no prime factor other than 2, 3, 5, and then let's take 7 directly. So 1 time. So 14 is equals to 2 into 7. So we got the prime factors for 14 is 2 into 7. Then x square can be written as x into x, as we know, we have discussed earlier. So that is x into x. So 10x is equals to 10x is equals to, as we know that 10 is equals to 2 into 5 into x. So directly we are writing. So now we need to factorize this expressions. So to factorize this expression, we know that there is a one common element in this all the 3 terms, that is, you can observe there is a 2 common in this all. So next, another element is present is x, because there is no 3 here and there is no 7, there is no 5, but there is x present in all the 3 terms. So let's see, one x is present. If you take any other x, suppose for one more x, there is no other x is here, there is one other x is present, but there is no other x is present in third term. So we cannot take the element must be present in this all the 3 terms, then we can take common from it. So there is no other term is present except x and 2. So here what we can do is 2x we can take common from this all. So let's write this expression is 18x cube minus 14x square plus 10x is equals to, we can write the 2x as common. So when we take in 2x in common, so we'll be getting, so what is left out is, when we take out 2x in common, the first term, what is left out, let us see, we have taken 2 and x, the remaining terms are, these are the terms are left out, 3 into 3, 9, 9 into x, x squared, so 9x squared is left out in the first term, so 9x squared we are writing, so it's completed, first term is completed, because when we have taken 2x in common, this is a common element, so using the distributive property we have taken this 2x in common, 3 3's are 9, x into x, x squared, then after there is a minus symbol, let's write the minus symbol same as it is, then after we have taken 2x common, then left over is 7 into x, 7x. Then after 2x we have taken common. This 5 is left out. There is a symbol of plus. So plus 5. So after factorization, we got, after factorizing this expression, 18x cubed minus 14x square plus 10x is equals to 2x into 9x square minus 7x plus 5. There is, we observe here, these are the factors. 2 is a factor and x is a factor. Another factor is an expression which is having the more terms, but this is not reducible expression. We cannot reduce this terms into any other expression, and we can go through in higher classes that we can find out the term factors for this expression except here. So until this 2x and this are the expression, they are the factors of this